Hello everybody, this is Leo. Today I've got a story for you folks. Guess what? It's a tale about Falco, but not that kind of tale about BPF, syscalls, runtime security and so on that I usually stress people about. Sorry, not sorry. Today is different, I promise. Today I will talk about how important it was for Falco to adopt Prow, the same CI/CD system Kubernetes uses, to automate the whole set of workflows and policies that the governance of an open source project requires. Anyways, my name is Leonardo Di Donato. I'm an open source software engineer at Sysdig, where my daily job is to code Falco, evolve it, and maintain it. As a maintainer of Falco, I also have to advocate and present its technology and all the hard work we do to continuously improve it as a software and as an open source project. So, here I am. Here's just a photo of me moving hands like a real Italian. Falco swag, the first one guessing the exact meaning. And since it's very likely that I will do other Italian hand gestures while speaking, please don't give up if you don't get this one. There will be other opportunities. You can usually find me on Twitter, GitHub, and generally the Webhooks with the nickname Leonardo. Feel free to drop me a line, ask me questions about Falco, eBPF, kernel, whatever. No problem at all, I like to socialize. When I first joined Sysdig to work full-time on Falco, which is now the first runtime security project incubated by CNCF, honestly, the contributor experience was not that good. Falco, created in 2016 to parse kernel and container events and detect security threat from them, was just donated to the CNCF at that time. Initial efforts to provide healthy open source governance were already being put in place, but they were not structured at that time. Yeah, we had an initial continuous integration system built on top of Travis CI, but it was honestly causing more troubles than benefits. We still had the building and testing infrastructure for Falco drivers, kernel modules, and the BPF probes internally at Sysdig, and we needed to bring it in the open. The one here in the meme is me the first days I joined almost 2 years ago, The repositories in the Falco security GitHub organization had zero or near zero automation. There were policies, but no one or nothing enforcing them, nor they were easy to discover for the community. Pull requests were often merged in by the same author without reviews. There was not a clear, transparent, auditable path for maintainers, to not mention external contributors. The list could continue, but you got the point. So, hey, no blame. We are all here to learn and improve and do things better and better. Open source is about culture, first of all. The only problem was I didn't have enough time to build a custom CI/CD system for Falco. We all know that testing and automatically verifying the code we merge into our repository is a crucial step towards the creation of good, maintainable and successful software, right? But that's just one of the things that revolve around the code, especially around open source code. But neither I did have spare time to create an automatic, easily configurable and auditable policy enforcer system. And for the same reason, spending hours by reviewing and double-checking every single action performed on GitHub from other contributors, whether they were following the policies or not, whether they were respecting contributor workflow or not, on various repositories in the Falco GitHub organization has never been an option. For evident reasons, this cannot be a task for a human. At the time, the team working full-time on Falco was just the two of us, me and my friend Lorenzo. Therefore, we needed to focus on writing eBPF code and C, C++ to improve Falco, first of all, not reinvent the wheel. However, we couldn't leave out or ignore this topic at all. So, how did I solve this problem? I started thinking of other successful open source projects from which to borrow ideas and best practice. I asked myself to look for something already implementing most, if not all, our needs to create a healthier open source environment and better open source software. A typical example of a successful problem solving, coping. I soon looked at the Kubernetes and here came into play Prow. You might not know it's Prow, but if you contributed to Kubernetes or interacted with some of the issues or its pull requests, For sure, you somehow already interacted with it. Have you ever met Kubernetes CI robot? That's just one of the faces of Prow. Prow is advertised as a continuous integration system based on Kubernetes. Well, it turns out it's way more than that. It's a platform for automating our open source GitHub code lifecycle too. It was built for Kubernetes on Kubernetes because Kubernetes already ships some of the features needed for continuous integration, continuous deploying systems, and automation. Leveraging pods, you can containerize your builds, craft test runners that will execute your test suites, making everything more self-contained and reproducible. But since pods are just a bunch of containers, you can also check out your open source code by using init containers. You can share volumes, upload build or test results using sidecar containers, and so on. A lot more. By using config maps, you can also check in and roll out configurations in a declarative way. With secrets, we already have credentials management. And do not forget custom resource definitions. They can mean pretty handy if you want to build a continuous integration system, because they let us define controllers to interact with custom resources dedicated to testing. With custom controllers, you can also implement different triggers for different events. For example, you can write a controller that listens for GitHub webhook payloads or GitHub events, or even one polling at a fixed interval some other Git platform. You can schedule custom resources on different clusters or in a different namespace, and so on. A custom controller could watch over the status of the custom resource definition, and whenever it's completed, can perform other actions. So basically, they are very powerful mechanisms that make scheduling, allocation, customization of flows easier. Furthermore, Kubernetes gives us the freedom to do not worry about scaling and scheduling since it's distributed, it's fault tolerant, and it's declarative. These are all the features that Prow inherited. Also, Prow can span across different repositories and different GitHub organizations if you want. This means we were able to deploy the same system over every Falco security project, so to provide to the Falco community the same contributor experience disregarding the precise repository or project they are contributing to. For all these reasons, it seemed perfect for me. And in the end, Poiana, the name we gave to it, helped us spending a lot less time caring about CI/CD and open source automatic governance, allowing us to invest that time in more Falco coding. Having it in place since more than 1 year, I also noticed that having the same recognized and mostly automated contributing process in place for different repositories helps people. It increases their confidence in contributing because after their first attempt or contribution, they don't have to learn and adapt to a different process for doing the second one, maybe on a different but related project. Honestly, as a CNCF maintainer trying to improve its software while also increasing its community and making it healthier, I couldn't ask more. But what's Prow? Let's give a deeper look at its architecture and how it's made. It's composed of various microservices that take advantage of the Kubernetes functionalities, as said, to provide a set of core components, mainly the one depicted in this diagram. This architecture, as you can see, is pretty modular. It allows for extendability and eventually replacement of components. The core piece from which to start is the Prow job custom resource for sure. It lets us store the state in the Kubernetes API server. Every Prow component is a custom controller dedicated to managing Prow jobs somehow and for some purpose. For those interested in more details about the life of a Prow job, I put a cool link to read in the slide. Anyways, Prow has different types of Prow jobs. The type of a Prow job specifies when and how it will be triggered. The more common one is the one called pre-submit. This type of Prow job runs on pull requests and it can be triggered automatically or be triggered by a / command. They usually run as Kubernetes pods and report their status to GitHub in form of GitHub status checks. But you can also run Prow jobs resources on different execution platforms like Knative or Jenkins if you feel brave enough, We can trigger them for different purposes too. We can trigger them for building, testing, even publishing the artifacts of our project. We can run them when a pull request is merged in or just periodically. They give us a lot of options. But what's the component that manages the lifecycle and execution of this job? It is Plank. Plank is the main piece responsible for running the jobs within Prow. It sits there watching for changes to the custom resources, which means it looks for jobs created by Prow with agent Kubernetes. It starts them, updates their state, and terminates duplicated pre-submit jobs, which is a useful functionality when you push another change to your pull request soon after the previous one. So, does a Prow job not have a pod? Plank creates it. The Prow job does have a pod that's marked as completed. Plank updates the Prow job status according to the job exit status, either passed or failed. It also stores the logs of your job, but only on Google Cloud storage buckets last time I checked. Anyways, I know there are ongoing efforts to port this functionality also to other platforms. Instead, Arola is the service responsible for scheduling periodic Prow jobs. Here I put the definition of periodic Prow job I'm working on for the Falco Security GitHub organization. It implements a Prow job which scope is to mark issues with more than 90 days of inactivity as stale issues by letting our bot Poyana commenting on such issues with the lifecycle stale / command, which in turn invokes the lifecycle plugin. As you can see here, it's very simple to create Prow job and decide their frequencies, just a bit of YAML. You can put here almost whatever you want in form of a Docker image, also a container that runs tests periodically and things like that. The only limit is your imagination. Another essential part of Prow architecture is the hook component and the plugin system it provides. It all starts with GitHub Webhooks. But what GitHub's webhooks are? Well, they are a mechanism that GitHub provides us to listen on its events. It tells us who generated an event, who sent it, when, what the content was, and other related info. When a GitHub webhook is directed towards our Prow cluster, it reaches the /hook endpoint, exposed by the deck component we'll see in a bit. All our GitHub webhooks will go through this endpoint that simply pipes their payloads down to the hook component, which in turn, depending on what the webhook payload content was, will trigger the relative plugin. In fact, the hook component is just a tiny Go server that accepts GitHub events, maps them to actions, and acts as a plugins agent. It's basically a dispatcher of GitHub events to Prow plugins, to simplify. I suggest you to give a look at it by clicking on the link in this slide. As you have probably started to imagine in the previous slide, with plugins you can do awesome things, like honking at all the pull requests of your friends, like I do all the time. Jokes aside, Prow comes with some cool plugins by default. You can find all of them in the link provided into the slide, but it also supports external ones, and this is really a cool thing. Some of them react to comments on GitHub containing /commands, implementing a kind of chat ops flow. Others simply watch over other types of GitHub events like commits, reviews, merge, and so on. A notable one is the config updater plugin for sure. We would like to redeploy our controllers every time there is a configuration change, right? This plugin handles it. It acts like an agent that automatically reacts to events happening on the configuration files. And we love it. Instead, the trigger plugin determines which job to run depending on the config files and creates the corresponding Prow job resource, responding to the /ok to test or /retest commands. There are also plugins like the old one that labels a pull request with a label that blocks it to be merged by Tidal, another important component we are gonna talk about soon. Or the approve or the looks good to me and blunderbuss plugins. The latter provides statistical means to select a subset of reviewers found in the owner's file for reviewing and approving a pull request. Then, reviewers can take a look at it and mark it with the /lgtm command to signal the code is okay, or at least looks okay, in their opinion. Anyways, the pull request will be ready to be merged in only when an approver will approve it, either by the /approve command or by clicking the approve green button on GitHub. Do you want to see what's going on your Prow cluster? The answer is that. This component provides a dashboard to look at all the ongoing pull requests, their routers, what's blowing them to be merged in, their current state in detail, and recent Prow jobs. It also gives us a glance at the queue of pull requests scheduled for auto-merging by the Tidal service. Finally, it also provides the help on plugins and /commands available for every repository you enabled Prow for. This works pretty well to document your open source workflows and policies when you want to onboard new contributors in an easy way. I just mentioned Tidal 2 times, right? Well, Tidal is simply amazing. I don't know if it's pronounced Tidal or Tidal, but forgive me. It lets your bot automatically merge pull requests when the relative required GitHub status checks are okay. You don't have to do it by hand anymore. It uses the GitHub search query to inspect all the merge requirements. For example, in the Falco case, it ensures that a pull request is not merged until it got 2 approvals from maintainers, commits are signed off, there is no hold from maintainers pull request, it's not a work in progress or a draft pull request, the history has been based on top of the current master of Falco, the pull request corpus text contains a release note block for the future changelog, and finally, all the contexts, which can also be external continuous integrations jobs, not only Prow jobs, are green. And you can have a look at all of these merge requirements. They can vary from repo to in a visual form inside that. You can even see what precise label is blocking a pull request from being merged in, or if anything else is preventing it to be merged, when Tidal shows up in the form of a GitHub status check into your pull requests. As you can see in the screenshot here on the right, it's very clear about what the pull request is missing to be put in the merge queue. Finally, Tidal lets us decide the merge strategy we want to use, which is something I love because it helps me keeping the Falco Git history linear. Now, suppose you have Prow running from months, maybe about 2 years like in our case. The syncer component enters the scene. Its main duty is to delete completed Prow jobs and remove leftover pods. It also ensures to keep around the most recent periodic jobs, because Prow needs them to calculate when to trigger the new ones so as not lose the state. It's kind of the garbage collector of Prow. After 2 days it deletes completed Prow jobs, after 30 minutes it cleans up completed pods, but you can also configure these values if you want. At this point we just need a mechanism to get notified when our job's complete, right? We don't want to stay at Google Cloud Storage all day or other things like that. Here enters the scene the crier component. It detects changes to Prow job custom resources and reports the status changes. It can report to GitHub, which will cause GitHub statuses to show up, or it can report to PubSub services, to Gerrit, or to Slack. Notice it overlaps a bit with Plank. As a Prow user, you only want one of the 2 to do this job, but no worries, you can disable GitHub reporting flag, adding the --skip-report to flag to its deployment. Read more if you want in the provided links. Now that we know all the pieces in the landscape, what's the resulting workflow they implement? Let's see, for example, the pull requests and contribution workflow I implemented with Prow for Falco. For the sake of presentation, I'm gonna simplify it a bit, but you will get the sense. So, we have 2 participants here, a contributor and a reviewer. When the contributor sends a fantastic pull request on Falco, I'm happy. But what happens under the hoods? GitHub sends a webhook to the Prow hook component containing the details about this just opened pull request. The hook component dispatches the payload of the webhook to the Prow plugin, which, analyzing the owner's file of Falco, understands that no approver has already reviewed and approved the pull request. So, the Prow plugin, in the form of our beautiful bot called Poyana, creates a comment on the pull request to notify that the pull request is not yet approved, and needs to be. At the same time, the same payload gets dispatched to other Prow plugins, like the size plugin that simply labels the pull requests depending on the number of line changes. In the meantime, the DCO plugin verifies all the commits of the pull requests to ensure the author signed off them. because our contributing process requires the developer certificate of origin. At this point, the hook component adds reviewers to the GitHub pull request, and GitHub notifies them either via mail or via notifications or both, depending on their GitHub settings. Soon after, Leo, being a paranoid maintainer, comes to look at this new pull request, marks it with looks good to me /command, and eventually triggers some pre-submit job with some other /command. In this case, the trigger plugin enters the scene and contacts the Kubernetes API server to ask it to create a Prow job custom resource. Kubernetes does all its magic and runs this Prow job. When this job completes, depending on its code, the GitHub request is updated accordingly. Now, a maintainer can finally approve your awesome contribution, either by using the /approve command or by pushing all the green buttons on GitHub. The approve plugin wakes up again, verifies that an approver approved, leaves a comment in the pull request about this, and labels it with the approved label. In the meantime, Tidal is sitting there querying at all the GitHub pull requests. It notices that your pull request has now all the merge labels required, that it got the correct number of approvals from the maintainers, and so puts it into the merge queue finally. A minute or two later, your pull request will be merged in the default branch of Falco, and you will officially become a Falco contributor. Congratulations! I know. Now you want your own Prow too, right? So let's see the minimal steps needed to have one. Prow runs in any Kubernetes cluster with no or minimal changes. So first thing first, create a Kubernetes cluster. I will not show you how to do it. Sorry. Then you need to do three things. First of all, create a GitHub account for Prow to use. It will be your fantastic bot acting on behalf of Prow, like our Poiana. We call it that way because it's the Italian name for a kind of little falcons, by the way. Prow will ignore most GitHub events generated by this account, so it's important this account is different from any other you wish to interact with Prow. Also, ensure this bot account is a known member of the organizations you plan on handling, and that it has right access to the specific repositories it will operate on. Once created this new GitHub account, create a personal access token with public repo and repo status scopes. In case you plan on making it handle a GitHub organizations also, add the admin org scope. For private repositories, it needs the whole repo scope. At this point, it's time to deploy Prow. It has a utility called Tackle that guides you through the deployment of Prow components in a couple of minutes. Otherwise, you have to put on your YAML engineer hat and manually write the deployments, the cluster rule bindings, and everything else by hand. This is how I did it, and we are gonna see it in the next slide. And do not forget to create the secrets from the GitHub tokens. Generate an HMAC token for validating the GitHub Webhooks, and the OAuth2 token we created before. What's left to do now? Well, the usual kubectl apply. The last step is to add the webhook to GitHub. You can do this manually, but I suggest using the update utility that comes in really handy as shown in the slide. You now have a working Prow cluster. Welcome to the club. There are other steps and refinements that can be done, like configuring a Google Cloud storage bucket for persisting logs, or exploring the upcoming integration of Prow with AKS and S3, but for my sanity, I'm gonna skip this, and I left you as an exercise. Anyways, in case you want to take inspiration from our Poiana, you can take a look at Prow directory of the Falco security /test infra repository. Here you can find some little help to deploy your Prow. For example, you can use the deployments, role bindings, and role specs I already did to create Poiana in the subdirectory named cluster and save some effort. You will find here also the cron job for the branch protector component. We didn't talk much about it, but it's very useful to enforce policies on your Git branches. For example, I use it to prohibit anyone, even me, to push to the Falco master. Yeah, you could do it manually by clicking GitHub buttons, I know, but the whole point here is to do it in an auditable way for the community. So this way anyone knows it's in place, why it's there, when it was activated or might be updated, everything is transparent. Then you can also use the makefile I put in place to reproduce Poiana installations. If you run make Prow, it will look for the files oauth-token, hmac-token and unsplash-token from which to create the Kubernetes secrets and then automatically apply all the previous YAML files we mentioned. Remember to create those token files, especially the unsplash one. It is required by the Goose plugin to honk everywhere. Jokes aside, after make Prow you can now run make configs command and then the make plugins one. They will create config maps from the configs YAML and from the plugins YAML file. We say that Prow plugins are just subcomponents of the hook binary that register event handlers for various types of GitHub events, right? These event handlers are provided with clients and agents that give them access to the configurations, the Prow jobs, GitHub, owner's file, secrets, and more. Anything that receives GitHub Webhooks can be configured to be forwarded to them and act as an external plugin. And this makes Prow even more powerful, allowing in-cluster or even out-of-the-cluster plugins and integrations with other bots or infrastructures. Well, let's make a plan together to create a simple custom plugin for Poiana. We need to do the following things. Write a little Go server that handles incoming webhook referring to issue and pull request comments. We can use the same Go packages Prow uses for its own internal plugins. So the task is not that difficult, as you'll see in a second, because those packages make our life easier by providing us a lot of helpers for obtaining the configs, the secrets, and an already configured GitHub client, and so on. Then we have to create a Docker image exposing this little server and create a Kubernetes service and deployment using it. At this point, what's left? The usual kubectl apply. But remember, we also need to add the external plugin in the plugins config map of our Prow cluster. How? By creating a pull request towards our test infra repository. Once it will be approved and merged, the config updater plugin will take care of automatically update the config maps. I wanted to make Poiana aware of who it is. For this reason, I created a plugin that gives it the ability to reply when /Poiana command is used. It's called Say My Name Prow plugin. It's under my GitHub. I put the link to it here in the slide so you can inspect it later, but we are gonna see a bit of its code right now. It's very simple. Here we are. Let's briefly look at the main method of the Say My Name custom external Prow plugin. As you can see, it's pretty simple. We instantiate of the plugin by using the helpers that Prow provides us, as I mentioned before. We validate those options, then we use utilities to grab the secrets, and with those we instantiate a GitHub client. Once done, we can pass down this GitHub client to the server. Also, Prow provides us an interrupts library, which is used for handling the interrupts of the server, and a method to serve the help of the plugin. Here I created the serve HTTP method to make our server struct instance to implement an handler interface that the HTTP MOOC server requires. As you can see, all I do is validating the webhook through the facility that Prow provides us, the validate webhook method, and then I pass down the webhook payload to the handler. As you can see, such handler just ignores every event type different than issue comment, When the event is an issue comment, it basically unmarshals the payload and spawns a go-routine to handle such comment. This go-routine calls the handle issue comment method, which basically first checks the issue is not closed and the comment was just created. At that point, basically it logs some information and it matches the string by checking that the content of the comment contains the /poiana command. If that's the case, it randomly chooses an answer from an array, from a slice, and then use an helper to format the response, commenting on the same GitHub issue. As you can see anyway, in this repository, I also provided the Docker file, a makefile, build it and push, and an example deploy YAML that you can use to deploy this custom example external plugin for Prow on your own instances. And here we are, this was the result. I can't tell how happy I was when I started spamming all the issues and pull requests with this new / command. I was in a rush, so it was in nighttime in Italy, and my colleagues started writing me, what are you doing? Well, it's not me, it's Poiana, it's here to stop the drama. In case you do want to have some fun too, here there are some ideas in the Prow topic that came to my mind. Well, first thing we need to do is to enable the GitHub API proxy to optimize Prow against the GitHub API limits. We could also think of spawning Prow jobs both on Kubernetes but also on external executors to verify the Falco drivers installed correctly on different operating systems, different kernels, either when containerized and when not. Or you can use what you already said about creating external plugins, and you can help us creating custom plugins for linting the C++ and the CMake files of Falco against a set of conventions. Or even better, we can create together a custom plugin that automatically prepares a pull request to release Falco version and updates the changelog using the release notes in the pull requests when it detects the corresponding milestone as being completed. There's a lot more, so it's just your call. Join our Wednesday community call so we can assign some tasks to you, please. Also, this story has come to an end. Thanks so much for coming. Feel free to drop any questions you have now or to contact me later. Also, we welcome a lot new contributors. Have you seen the previous slide? There's always a lot of work to do. Now we have Poiana in place for more than a year. Everything is in place for a healthy, transparent and a clear path to participating in open source. So it's very simple to contribute to one of the Falco projects, even to Poiana itself as said. Anyway, my direct messages are open. You can find me with Leonardo nickname on Twitter, on GitHub, on the Kubernetes Slack. Feel free to get in touch with me for everything about open source, Falco, ABPF and so on. Ciao!